Okay, which of these have to be true? First of all, we have no idea what these functions look like. So clearly h could be some function where the definite integral from 0 to 2 was not positive. For example, if h was the opposite of x squared, the upside down parabola, from 0 to 2, the definite integral is definitely negative, not bigger than 0. So easy to rule out Roman numeral 1. For the next two parts, they both deal with first derivatives. So let's take the derivative of these. d dx of both sides of the equation equals the equation h prime of x equals h prime of 2 minus x. Don't forget the chain rule. The derivative of the inside is negative 1. All right, for part 2, let's put in x equals 1 into our differential equation. Substitute x equals 1 in, and we get h prime of 1 equals the opposite of h prime of 1. This is literally impossible. A value can't be equal to the opposite of itself unless that value is 0. So this must be true. H prime of 1 must be 0 because h prime of 1 must equal the opposite of h prime of 1, which is only possible if it was 0. 2 is true. Which brings us to 3. Does this have to be true? It's saying that h prime is equal to 1. It's saying that the slope of this h's graph is 1, both at x equals 0 and at x equals 2. Does the slope have to be 1 there for some reason? We can easily find a case that is a counterexample for Roman numeral 3. For example, let h of x equals the linear equation 3x. So h of x, if it's equal to h of 2 minus x, gives us, when, say, x is equal to 0, first let's take the derivative again, using the chain rule, and now let's substitute x equals 0 in, and we get this equation. So this is saying that h prime of 0 must be equal to the opposite of h prime of 2, and it's saying that it has to be equal to 1. Why would that be the case? After all, if h of x was 3x, then h prime of x would be 3, and h prime of 0 would be 3, and the opposite of h prime of 2 would also be negative 3, neither of which is equal to 1. So it's an easy rule out. That's not true. Doesn't have to be true at all. So the only answer for this problem is B.